I hope you had a good start and connect with the keynote sessions. I think we had one other session as well, and then some snacks, obviously. So my name is Stefan Schmidt. I'm a tech lead here at Linaro. I worked on the compute side of things for the Qualcomm ecosystem for a while over the last year, basically working on the Snapdragon X Elite laptops. And one of the focus areas I was looking into was like how we can get a full end-to-end video acceleration going from the browser down into the hardware and really offloading everything to have like the real benefits you want to expect from that. So I want to take you a bit like on a journey of what we did there, what are the gaps, what is the work in progress, what are future thoughts about that. So let's get started. So the agenda is pretty simple. I'm talking about the Iris driver, which is in the upstream driver and the upstream status of that. Talking about a bit about the laptop use cases, what we're looking into, why we want to do that. I mean, they're quite obvious, but still I want to make sure that we are clear on that. Then looking into the existing media frameworks that we're having, how to support, what we can do, what is working, what is the gaps, basically, what we see there, and then going one step up, going to browsers and Chromium, Firefox, for example, and also other applications as well. At any time, if you have questions, just interrupt me. There should be a few minutes at the end for questions, but you can do that in the session as well. Okay, so first part here, the CPU driver and the V4Linux 2 API, how to use that, how that is how that is integrated into the kernel, and so on. So what we have is the Iris upstream driver. So for a long time, there was already, there still is, Qualcomm driver for all the video processing units and so on to do all the decoding and so and then encoding side. And that's called Venus. Venus is still there. Venus is still supporting all the existing hardware and so on. And now Iris is a new driver that is going to take on all the new hardware coming out. So it's starting with X1E, that's the X Elite platform. And then you have 8550 and 8250. So 8250 is the one SoC that's actually overlapping. So we have support for 8250 in Venus as well as Iris. So that was one of the requirements when the driver was proposed upstream, that we at least demonstrate that it's also capable of running some of the older hardware. So there was a bit of a back and forth on that. But that's the three currently supported SoCs. There's more to come. There's actually more on the main list already being prepared on that. So the core support for this one landed in 6.15. There was a long journey for that, so I think we ended up with like version 9 or something. The Qualcomm team was working on that, getting that all in. And it also started with a lot bigger surface of features and so on. So initially it had the full feature set of like different codecs, encoding, decoding, and all the bells and whistles. And then in the initial stages of the review, it was very clear that it's just too much code to actually look into. That it was just too much, overwhelming the maintainers to actually give review and feedback on that. So they trimmed it down. They made sure that they only have like one codec support. So it started with H.264 and just the decoding side. And then obviously the important part here for us to get all the core infrastructure in place, making sure that that is working correctly. And we have that well integrated with the V4Linux. So we have like the full memory-to-memory user space API. We're using that from the media frameworks and so on. So, but as I said, there's upcoming functionality. Right now, there's a patch set already, also at version 5, about other codecs being supported, HEVC and VP9 being listed here. I think that's getting pretty close to be merged, but we will see if there's another spin of that or not. And then the other big item that is missing is the encoding part. So we don't have any encoding hardware acceleration at all at the moment in Iris, but that's something that is going to be added. The code for that was actually posted when the initial set was posted, so the code is there, but obviously after all the changes and the review cycles and so on, that need to be rebased and bring up to speed again. So that is the status we have of the driver. So that is quite good actually. We are happy that we have this thing is landed, but there's a lot of more work on top of that, right? So but if you look at for example, at the V4Linux compliance tooling, you can see you have like the video memory-to-memory multiplier. That's one of the capabilities being added. Streaming is there. So it's quite full features in terms of like what it offers in terms of the API for V4Linux, which is a good start already. It's a stateful decoder. And if you look on the right side, you can see that there's a listing of the available codecs. So that is one is used with all the patches that are still pending on the main list and so on. You can see like there's other profiles for VP9 and HEVC as well. So it's like part of the normal tooling that we have. And all the video for Linux compliance tests are passing, so that's quite good actually for this driver. Okay, so what is our laptop use case? Quite obvious is that we have hardware in there, and we want to use that to make sure that we are more power efficient, getting more battery life out of these devices. So when we started in compute and looked at different use cases, what we could really demonstrate on these kind of Snapdragon devices, this was one that was showing out as an end-to-end use case. Because we all have done, or not everyone, but the space of like doing VPO drivers, making sure that you have a setup where everything could be offloaded for a very specific embedded use case for a product you're doing with a niche or like a narrow view on what is needed. That was all fine. That was like, you can get that work together, you can like multimedia frameworks working or even a browser or something like that, that is fine. But going into a complete general purpose use case, that was something else where we like looked how can that be done and where are actually all the gaps are, what need to be done to get that into a good setup. So as I said, obviously we want to have CPU savings. On the compute platform, that is not so much of an issue of displaying the video at all. It has more than enough power to even go to higher resolutions and do that in software encoding, but obviously that burns a lot more power and you're reducing your battery life. But on mobile processors, for example, that's one of the things where I think you might not even be able to play a specific video in a specific high resolution if you're not able to use the hardware offload. So that's a different use case there as well. Yeah, but I touched on that already. So the general purpose versus the embedded use case, there you have like a clear product, you have like all the use cases defined up front, you have like a clear set, and then you can work on that, integrate all of that, make sure that you have all the pipelines from the media frameworks in place, everything is configured correctly and so on. But that is very different from one of you guys taking a laptop, installing Linux on it, your favorite distro or something, and want to make sure everything is working out of the box for video offloading. That's something that is not working today, but that's something we want to look into. Okay, so what do we have? In terms of media frameworks, we only looked really at GStreamer and FFmpeg. These are the two big ones. There are niche markets as well. And we will see later with Chromium that they are not using any of these, for example. So that's another market. But in general, that is actually what we looked for. So on the left side, you can see one example pipeline that we built up. And this is just playing one of the videos and then putting that into the Radiant thing and getting it into full screen. But it's not a big thing to do. But one thing you need to keep in mind here is that you manually specify the specific element to do a video for Linux decoding for a specific codec. You put that in there, you make sure that that is correct, that need to match up with the video file you're having and so on. There are some ways of detect things, but it's not really like a fully automated way where on, for example, an x86 machine, it's a lot easier to just say, we want to have like video offloading enabled or like doing the acceleration on that one, and things are worked out in the media frameworks on the way for that. So there's no automatic pipeline creation, at least happening there. I'm not a GStreamer or FFmpeg expert. I know that there are some parts that you can automate some of these things, but in general, it's a lot of work. Same on the FFmpeg side. So if you use FFplay, you select the decodec option there. Again, capability detection and automatic pipeline creation is something that we are missing to really make a full out-of-the-box experience for a user to make that work. Okay, and with that, we come to the bigger pieces where we actually look into, because that is where we drill down from in terms of requirements. So we looked into Chromium. So Chromium had good video offloading support on ARM CPUs for a long time. Basically, for all the Chrome OS devices, you had that enabled, things are working, but that's a product scope, again, what we are looking at. And a lot of this stuff has been hidden behind like Chrome OS, ifdefs, or specific other parts of the stack. So it worked out if you have like an integration team that worked on a product, that was all fine, but not for a general purpose use case. Luckily, over the last 1 to 2 years, there have been a lot of movement as well to harmonize this different code passes between Chrome OS and Linux, making sure these things are getting hit by a normal Linux build as well. And you still need to do nowadays, you see like the enabled features set, that the command line, you still need to pass in to enable all the different parts to actually make it work on my system here. That's a lot better than it was before. Normally you needed like a lot of patches actually on top of that. That is no longer the case. So for my own build of Chromium, I only have like one patch, and that is very much Iris specific. and the rest is actually there. I mean, to be fair, there's like 2 more patches or so for integration purpose to like have these command line arguments being run by default and stuff like that. But there's no big code changes anymore. And also there's things like the use of Chromium normally looked like for specific devices, like device, what's it called, decoding 0 or something, to make sure that it finds the right device. That was a symlink to video. That's changed nowadays as well, so you don't need to do any changes compared to mainline Linux anymore on that. But you need to still enable the command line features on the the features on the command line. But if you do that, you can see on the right bottom, you can see like the GPU features tab, and there you can see like to get the full video decode hardware accelerated as well. What I mentioned before, this is not using GStreamer or FFmpeg or something like that. They have their own Video for Linux interface to like work with the kernel side and get that all sorted out and so on. So that is one of the other big stacks there as well. On Iris, we have like a small problem still where we have like, I need a workaround for that because Iris expect to have like a minimum buffer size of like 16 by 16. The first thing that Chromium requests is like 0 by 0. And then Iris said, no, I don't have anything like that, and then it goes to fail or something. I need to figure out if there's some call missing in Chromium that's actually querying the capabilities and do that correctly or not. But right now I have something hard-coded in and that works. But that's not a big thing to sort out, hopefully. It's getting a bit more dark on the Firefox and others application side. So Firefox currently does not support any of these. So it uses FFmpeg in the background, but it's not working to really like get like the full decoding pipeline, everything up and running. So Brian from the landing team we're working on, he's looking into that from video perspective, putting together a proposal, mostly talking around like how we could extend FFmpeg using the prime and so on to make that work. So that's something that is work in progress right now. We don't have any code for that. It's more like via scoping, trying to understand if what can be done and then working with the community to figure things out there. But that really gives a good indication on if you don't have like a single purpose thing with Chromium where they already did the work on that, but you go to other applications, for example, like ZoneMinder. For people that don't know, that's like for security cameras where you have like specific detection of like movement and so on. So it uses any kind of like video decoding capabilities would be really helpful on like low powered devices and so on. And then obviously like video editors, KDN PDV, KDN Live, and so on, and things like OBS Studio would all benefit from doing the acceleration for decoding and coding as well. But for all of that to work, we really need to have like a better setup of like how we can detect the capabilities, how we can do an automatic like using of them to make sure that we're creating the pipeline in the correct way. And that is something that we are going to look into over the next year as well. It's not our main focus, to be fair. So that's something we have on the sideline, but we want to enable that and make that a bit better. But we also need to find a bit more like understanding in the community because we are not really driven on the media framework side and so on. But yeah. Okay, so that was all in terms of slides I had for you guys. But I'm more than happy to take questions, whatever we have there. Don't be shy. Nobody? Okay, so there is 2 more things for that. So there is a compute BOF that I thought this evening or tomorrow evening, where we have like a lot of other things going from the compute side. Video is just one of them. So we're going to talk about that, what's going on there, and then you can also just join in, ask questions, and so on. And I will have a demo on the capabilities of like doing the video playback on one of the ARM devices at Demo Friday. So you can join me there as well, ask questions, or just grab me somewhere in the hallway or something like that. Okay. Thanks a lot, everybody, and have a good day.